Hello everyone, welcome back to my channel. Let us discuss two important mathematical theorems used in the vector calculus. They are Gauss Divergence Theorem and one more is Stokes Theorem. These two theorems are also very helpful in obtaining the Maxwell's equations from the various phenomena which we observe in electrostatics and magnetostatics. Now here first let us discuss the Gauss Divergence Theorem. In Gauss Divergence Theorem, let us consider first a vector field, say A bar, and let us consider in that vector field a object like this cube. Now what we have to find out is within this volume made up by this cube, let us take some point say P and find out what is the divergence of the vector field A bar at point P. Now by divergence we mean that it is outward flux per unit volume at the point P as the volume tends to 0. So that is the meaning of the divergence of the vector field. So that means we find out what is the outward flux at the point P over a small volume element as the volume element delta V tends to 0. Similarly, let us do it for other points in this volume, say point Q, R, S and so on. For all such points, let's find out what is the divergence and go on adding it over all the points. So this is one calculation. So let us see mathematically what is the divergence of A bar gives us. So the divergence of A bar is given by the dot product of del operator with the vector field A bar, which is given by dou AX by dou X plus dou AY by dou Y plus dou AZ by dou Z, where AX, AY and AZ are the components of the vector A bar along x-axis, y-axis and z-axis. Now according to this definition, outward flux per unit volume, you can write it as limit of outward flux of A bar by volume delta V as delta V tends to 0. So this is equal to this definition of divergence del dot A bar. So therefore we can write del dot A bar is equal to this limit of delta V tends to 0 of the closed surface integral. So this outward flux of A bar over the surface which encloses the volume you have to do. Therefore it is closed surface integral of A bar dot ds bar by delta V. So that is we have to take this surface which encloses this cubical volume. So it's a closed surface. So over this surface I take the surface area element say ds bar and I find out what is the outward flux that is given by A bar dot ds bar. Similarly for another area element ds bar like this. So I go on doing it for all the area elements making this closed surface and then add it. So that means I get the closed surface integral of A bar dot ds bar. So limit of delta V tends to, as delta V tends to 0 of the closed surface integral of A bar dot ds bar by delta V is equal to divergence of A bar. Now let us remove this limit part, then we will get a integral here. So integral with respect to when I transfer this delta V over here, so the integral will be with respect to the volume. So that means I get a volume integral. So volume integral of del dot A bar dV is therefore equal to the closed surface integral of A bar dot ds bar. So this is the statement of the Gauss Divergence Theorem. So what is the meaning of this? So what is exactly the work done by the Gauss Divergence Theorem? So let us summarize. So here we are finding divergence of the vector field A bar at each and every point over the given volume and sum up for all the points in the given volume, right? On the other hand, we are finding what is the outward flux over the area element. So flux of A bar over the closed surface enclosing the chosen volume. So this surface which encloses this volume, over that surface we are finding what is the outward flux, that is A bar dot ds bar. So if we do this calculation over the whole surface, then these two calculations are one and the same, both give us the same result. So that is the meaning of the Gauss Divergence Theorem. So that is what is meant by this equation here, that is the volume integral over each and every point in the given volume of divergence of A bar is equal to the closed surface integral over the surface which encloses the given volume of the outward flux, that is A bar dot ds bar. So all the area element making this closed surface, if we do this, then both of them are equal. So using the Gauss Divergence Theorem, we are able to equate a volume integral to a closed surface integral, or a triple integral to a double integral. Here we have to remember that the lower order integral, that is double integral, is always a closed one. So this is the meaning of the Gauss Divergence Theorem, which is used in the vector calculus and which is very helpful for us in the discussion of the Maxwell's equations.